Hello everyone and welcome to the introduction of conic sections. This is the first part of the Precalculus series that is under the Philippine K-12 curriculum. So, what are conic sections? Conic sections are basically curves formed by the intersection of a plane and a double right circular cone. That's it. But I think it would be better if we see it visually, you know. And right, it states there that it is a curve, but it is more than one curve because just like here in this presentation, it is curves formed, right? So that means there are multiple curves formed by intersecting a plane and a cone. So if that's the case, how they are formed to be particular. Yes, we get the idea that we are intersecting a plane and a cone, but in what way that by intersecting them, we will have multiple curves, or rather, we will have multiple types of curves formed because of it. We will know it by using GeoGebra. All right, here. First one. So here I have a demonstration that I made by myself. So we have two shapes once again. Here, if you see a black rectangular shape, that is a plane. If you see these circular cones, this is a double right circular cone. It is double because there are two circular cones. Let me change its view. All right. You see, there are two uh, circular cones. They're connected to each other actually. And yeah, it is called double because of it. And it is called right circular cone because the orientation of the cone itself is vertical. All right. So now let's have an experiment. Like, okay, at this point, the plane intersected at this part of the curve, all right? At this part, like that part itself. Now, take a look at the red dotted line, right? This one, right? This red dotted line tells you the formation of the curve when the plane is intersected at this point or at this location. Now take a look at this one. If the plane is intersected at that location and it is perfectly horizontal, expect that you will have a circle formation. This looks like a circle, you know. It is, in fact, a circle. All right. Now, what if we try to tilt it upward? Like, right? It's like this. Like it's like a yeah, horizontal line. Now, what if we tilt that upward? We tilt that upward. Like do a little bit of rotation. So let's try that. All right. So I'm just gonna control this point F and let's move it up. Take a look what will happen. Okay, up. Now let's take a look. There we go. Now, if you're going to observe at this point, it looks like initially it's a circle, but when we move it up, what happened? It enlarged. So it's no longer a circle, but an oblong shape. Oblong is basically like it's a round shape, but it's not a circle, you know. So this oblong shape is what you call ellipse. So at this point, if you encounter this type of shape, this is what you call ellipse. All right. Now let's move it even further. Okay, it's still an ellipse, you know, as it almost touches at this corner of this top base of the cone. It is still ellipse. All right. Let's try to make it as if it touches to the circular cone. To the base of the circular cone. All right. Let's take a look. All right. So yeah, at that point, it looks like it's still an ellipse. Once it touches to this point. But if we go beyond that, like this, beyond, all right, in a way that it forms a U shape. That is another curve that they form. This curve is what we call as the parabolic curve or parabolic shape. Or one word, it is a parabola. That's it. In fact, this is actually a graph of a quadratic function because a quadratic function is a U shape, right? It's a U shape. And that here is a uh, example of what a quadratic graph would look like. All right. Okay. So yeah, we have that. So what's next? All right. Now, let's just say we want to make this plane into, let's just say, almost vertical, right? It is diagonally oriented. Let's make it almost vertical, right? Let's orient it vertically as much as possible. So we go further up, we set it even more, even more. So if you're going to observe, it's still a U shape. You know, it is still a U shape. Okay, nothing changes. But if we go even more, look what will happen. Okay, and go and okay. Now take a look. Yes, it's almost vertical, but that's not what we're actually are focusing on only. But it's also its intersection. Because take a look at the intersection of a plane and a cone at this position. You see above, yeah, it's still a parabola, right? It is still a parabola. It's still a U shape. But if you're going to look below, like below it, it's also a parabola, you know? So, meaning, if it's almost uh, vertically oriented, there is a chance that you will form two parabolas. And these two parabolas, they face against each other. If I remember correctly, if I say against each other, I think opposite. But okay, if I said it in the wrong way, well, let me just say it in another way. Basically, there are two parabolas, but they are facing in opposite direction. Much better. I think that is the correct way to say it, all right? I might be using phrases in the wrong way, but this is the right way, all right? So, going back, it seems like we have two parabolas, but they are facing to its opposite direction. One is facing upward, one is facing downward. This is what you call hyperbola. There are two parabolas, but they face at the direction that is opposite to one another. All right? So you see, first we have a circle. Second, we have an ellipse. Third, we have parabola. And fourth, we have a, what's that again? Hyperbola. These are conic sections. All right? But if you're asking me, are there any shapes that are formed by these intersections? Yes, but they are not called conic sections. All right? These are what you call degenerates. I'll show you. What if we have a plane, but it is halfway through the cone? All right? It is not only halfway through the cone, but it is horizontally oriented. Right? Let me just remove this plane. Okay. So what if it is like this? Okay, it's like this. Now, if it's like this, like the plane is halfway through the cone, so what will happen? If it's like that, you will not form any shape. Rather, you will form a point. Point as in the dot itself. So this is a degenerate case. You will form a point, right? And another degenerate case is what if we try to have a plane that is, yeah, it cuts the cone into half vertically. All right. So let me try doing that. Okay, let me just have this, the plane. All right. So let me just include the other points. All right. Let me just say it goes down right here. All right. Let's just say let's start with this one, by the way. Like, what if we have this? Okay, we have this. If you see this, you may be thinking, okay, what of it? It looks like a hyperbola, but in actuality, that's not a hyperbola. You know, it seems like we have two straight lines intersect to each other as if they make a X shape. You know, so that's another degenerate case here. All right, but let's focus at this part. Like, what if it is perfectly vertical? Wait, what if it's perfectly vertical, just like this? All right, just like this. Okay, so let me just move this here. All right. Huh. Wait, just give me a second. Wait. There you go. Much better. It is vertical and it cuts the cone into half. Right? Cuts the cone into half. Now take a look at the results. Just like earlier or recent shape that I showed to you, you will form an X shape. X shape. It's not a hyperbola. It's an X shape where you have two lines that they intersect to each other. So this is a degenerate case. All right. So this is not a conic section. This is a degenerate case of conic section. All right. So now, I think we can switch back to the presentation. All right. So let's take a look at our observation. All right. Let me just shrink my camera a little bit and I'm gonna put it down right here. All right. So let's start. Wait. Yeah, let's start first with this one. Wait. Let me just fix. Right. There we go. All right. Now, if the plane is parallel to bases, then it form a circle. Like, what if it's perfectly horizontal? There, it form a circle. All right. Now, if the plane is tilted where its corner at most touches the corner of the top face, then it forms an ellipse. That is based from our observation. Then here, if the plane is tilted where its corner goes beyond the corner of the top base, then it forms a parabola. And lastly, if the plane is tilted where it is almost vertically oriented, then it forms hyperbola. All right. Again, this is based from putting the plane at this position, okay? At this position, okay? We base it, uh, we base it where the plane is at that position, all right? So if this position is our basis and we tilt the plane, we can have these results, all right? Now, the degenerate cases here. If the plane is tilted where it is vertically oriented, where it cuts the circular cone, it's cone by the way, it's not one cone, into two equal parts, then it forms an X shape, just like this. If the plane is tilted where it is horizontally oriented, where it cuts the circular cone into two equal parts, just like this, particularly in the vertex, the part where the two cones connected by the tips at that point, then it formed a point. All right. So these are the degenerate cases. All right. So let's finalize everything. Okay, let's go here. Conic sections are basically, again, curves formed by the intersection of a plane and a global right circular cone. So there are four types. One, a circle. Two, parabola. Three, ellipse. And four, hyperbola. The degenerate types are the X shape and point. Wait, let me just, there you go, point. Now, here, visually speaking, we know how. Oh my God. So I think I have to recheck my grammar sometimes, all right? But yeah, visually speaking, we know how these curves look like. But since we are in the math subject, what if we have a given mathematical equation that represents them? Do we know if it is a circle, hyperbola, ellipse, or not by its mathematical equation or formula? If I give you this formula, is this a circle? Like, for example, uh, let's just say I have this one. Let's just say wait, hold on. Y is equal to x squared minus 1. Is this a circle? Or is this a circle? X squared plus y squared minus 25 is equal to 0. Is this a circle? So in here, we will learn that in the next topic. All right? For now, at least you know how they look like visually speaking, but this formula stuff, we will know that in the next part. All right? So see you guys soon. Goodbye.